Today what we're going to be doing is learning how to find the areas of something called sectors and annuluses. All right, so let's first of all talk about what those things are. So a sector of a circle is like a slice of a pie. Okay, it's the region between two radii and the intercepted arc. So this purple area here to the left. Okay, so it's like a slice of pie or a piece of pizza. That's called a sector. An annulus is like a donut. Okay, it's the region between two concentric circles. Concentric circles came up a long time ago. It just means two circles that share the same center. Okay, so it's really like a donut. So we're going to be finding areas of slices of pie or pizza and donuts. Okay, so now that you're all hungry, let's do some math. All right, so here's how you find the area of a sector. I put formulas here, but honestly, if you just think about this logically, it's going to be so much easier. We want to know a fraction of the area. Okay, so I don't want to know the whole area of the circle. I only want to know a fraction. And if you remember, we did this with arc length. Okay, that fraction comes from that central angle or the measure of that intercepted arc. So it's just that angle over 360 times the area of a circle. So just a fraction of the area. A donut, annulus, is really just taking the area of the large circle and subtracting the area of the small circle. Okay, a lot of times, not always, but a lot of times they'll use capital R to represent the large circle and a lowercase r to represent the smaller circle. Okay, so the formulas are pretty straightforward. Again, if you think about this logically, it goes so much better for you. All right, so let's start here. Find the area of the shaded region. Okay, so we're trying to find the area of my sector. So I know my area is equal to my fraction times the area of the circle. So my fraction is 45 out of 360 times area, we know is pi r squared. So pi times 20 squared. All right, so now we can reduce this if you want, however you'd like to do this. So 45 out of 360, that would be 1/8 times pi times 20 squared would be 400. So I can reduce that. I can take 400, divide that by 8, and I would get 50 pi. In my case here, I would have square centimeters. Again, if you want to take 1/8 times 400 in your calculator, go for that, but it's just 400 divided by 8 is really what's happening. So that's 50 pi square centimeters. And you can leave your answer just like that. Leave your answer in terms of pi. Let's try another one. It says the shaded area is 14 pi square centimeters and the radius is 6 centimeters. I want to find x. So this time I'm trying to find that angle, right? Remember, that's part of that fraction. So I'm trying to find x over 360 times, there's my fraction, times the area of my circle. So pi times my radius squared, which is 6 squared. I know that that area is equal to 14 pi. That's what we were told, right? All right, so let's clean this up a little bit here. I would actually divide both sides by pi because we have pi on both sides. So let's just get rid of that. So now I have x over 360 times 36 equals 14. All right, now this is where I like to do this mentally, but some people would like to divide both sides by 36 and then multiply both sides by 360. Okay. Also think about it this way. I'm going to show you mentally. You can do the algebraic way, the long way if you want. But 36 over 360, that reduces to 1/10. Okay, 36 over 360 is 1/10. So really I have a 1x over 10. Okay, so then I can multiply both sides by 10 to clear that fraction. I have x equals 140. So in our case here, that angle is 140 degrees. Again, you can grab your calculator and do all that algebra. I know you can. But if you want to think about that mentally, that's how that would simplify. Okay, let's take a look at an annulus problem here. We want to find the area of the shaded region. Okay, so remember I need to do pi r squared minus pi r squared. Right? So my large radius, the radius of the large circle here is 8. Okay, so it's going to be pi times 8 squared minus, now let's look at the radius of the small circle. I know the whole diameter is 6, which means my radius then has to be 3. So pi times 3 squared. All right, so we have area equals 8 squared is 64 pi minus 3 squared is 9 pi. So my area is 55 pi square centimeters. Okay, so 64 minus 9 gives me my 55, and that's how I get my 55 pi square centimeters. So for homework, you're just going to be practicing this. The areas of sectors on the front side, I believe, and then areas of annuluses on the back.